to get that down there a little bit closer. I don't know where I want it yet. That'll help support it. Tailstock off out of the way. Trip hazard out of the way. I slide it in there so I get a length measurement on it. 95.18. Yeah, we got a 16th to come off of that guy. So I think on this end we're going to take, once we touch it, we'll take 60 thousandths off. Got to put it right on the money. Harley guys want to make sure you hear them. This is whey oil here. Make sure all the chips are off of the wheys, and I'm going to go grab the tailstock, slide it back on. Yeah, it spun on us, the clamp. There it goes. All right, we got room to face it there. Move our steady rest. We still got to indicate it, by the way. Somewhere right there, that'd be good. All right, let's get it indicated. All right, I got about a little over 20 thou run out. Two thousandths. There's a half a thousandths. Let's see if we got them all tight. That one was a little bit loose. All right, let's re-indicate it. Moved it about a half a thou. You want to make sure you're definitely chucked well for this operation because we're doing our threading and you don't want it to slip. That's under a half a thousandths. That should be good. Okay, we'll get it faced and center drill, and we also have to relieve the center on this side since it's our coupling side. Get the steady rest down. Boy, look how straight that cut is. So that's that new bandsaw blade I put on there. Pretty nice. All right, I'm gonna just reset our DRO. We're gonna take 60,000. I'm gonna take that in 2 passes. Tell you what, let me kick the feet up. We're gonna go from 9, that's 9 thousandths, this is 11 thousandths. See if it'll help break that chip off. Yeah, that's a little bit better. So there's a little tip for you too. If you're fighting stringy chips, kick your feed rate up. It'll help break that chip off the faster you feed. And let's take one more cut. Looking up at the DRO, that's why I like my indicator down here. Sometimes that first cut wants to do that when it first engages the material. There you go. Well, you were doing good. Now you're not. Let's just let it finish. I don't want to get my hand up in there. That's the scary stuff right there. Sounded like it might have got my tool there. No, the tool looks fine. But I am going to reface that because I don't like it. When it does that, it just ends up marking up the finish there. But what I'll do first is go ahead and center drill it some, and that'll help relieve the very center of it so I can put a grooving tool in there and face this out a little bit. We're going to use that radius tool to relieve the center of it. We'll take it up in about 30 thousandths. I went ahead and cleaned this face up. I just took a couple more thousandths off that. We got a nice smooth face there. The center is relieved with a depth of 35 thousandths, and everything looks good. I've had a few people ask about why is it necessary to do this, and what I'm going to say is this is what I was taught. So we've done a lot of these pump shafts over the years, and every single one we have done always is relieved, and that's how they want them to. So I'm sure that this is an engineering design that was engineered years and years ago. But essentially, if you think about, you got this shaft and you've got another shaft, and they're screwed together with the coupling and they're butted up face to face. So you want both of those faces nice and true and perpendicular to the shaft, and you want it to seat right out here on this area and not in the center of the shaft, if that makes any sense. So if you're working with pump shafts, typically this is how you will find them, is relieved in the center. Every pump shaft I've ever seen has been done that way, and when I was told to machine them, that's what I was told to do. And same thing on this shaft right here. They wanted that relieved in the center on this one. All right, so we're going to put our live center back in the tailstock, and we are ready to move on to the next step, which is going to be, we need a thread relief. All right, so we need to cut a thread relief in here, just like we always do. We'll use a radius tool in that, make a nice round groove in there. And we're going to measure this and take it down about 5 thousandths under the nominal size. So we'll get the groove, we'll get it turned, chamfered, and then the last thing we'll have to do is thread it. Need a couple thread gauges. So this looks like it's going to be 8 threads per inch. There's our 8 leaf, and that's exactly what it is, 8 threads per inch. Okay, so we can figure out what our double depth is there, and then we'll just use our hook rule here. So it looks like there, so this was probably done on a CNC lathe. The thread started, it engaged right there. I'm going to call that 3 1/8 inches right there. So that'll be the edge of our undercut or our thread relief that we're going to cut. I already got my tool stepped off, and that is going to be 3 1/8 right there. And then so the thread gauge says double depth is 162 thousandths, so we'll go like 175 on this right here. And I should already have a 0 set. Let's see if I do. Yep, there's our 0. I'll go ahead and run some flood coolant on this tool as well. That is a 1/8 wide radius tool, by the way. That is our Walter MX22 insert. 1/8 wide full radius. It's probably going to try to chatter on me a little bit. This is where you have to, if you're going to plunge, all right, you hear the chatter. So before it gets bad, let's go ahead and slow it down. We'll drop it down into the first gear. Try to get under it. All right, it's not going to want to do it. So I want to make it a little bit wider anyway, so we're going to go ahead and just move it over. Let's move it over 30 thousandths and come in again. There's our 175, and we'll come back to our 0. That's why it's nice having this mag back indicator right here. And in this one, we can go ahead and take it into our 175 and go across the bottom. Clean up that side, clean up this side. Now I'm going to go ahead and back the tool off with our compound. It's going to cut that 29.5 degree right there on that edge. That looks pretty good. Good thread relief. We'll go ahead and put our turning tool on there, and I'll get a mic and we'll turn this, just turn this down. We want it down about 5 thousandths. This is a new spot that I'm trying for a lot of my tools. This is my Starrett mic set right here, this 0 to 6 inch. I've been keeping this inside in the office ever since I got it, but I think I'd like it out here now, and this is where hopefully it'll live. So we want the 2 to 3 inch mic there. All right, so 2 7/16. This is probably going to be pretty spot on. 2" 437. Let's see what it's measuring. 436, so I was off a little bit. All right, so we really only need about 4 thousandths to come off of that. We'll just touch it off. There's our touch off there. I'm going to dial in 4. And we'll let her feed down. A little slower than I wanted, but we're already engaged, so I'm just going to let her go now. Let's see what we landed on. 432. All right, so that's going to give us 5.5 dial clearance over nominal. All right, that worked out good. Last thing, let's not get sliced up with those guys. We want to put another tool here and put us a nice chamfer on the end of that shaft there. I'm going to slow it down just a bit for this guy. After we thread it, I'll probably come in here again and touch that up just a bit, but we'll go with that right there. That looks nice. And while we're at it, while we got this tool in here, let's see if I can reach it. Yeah, let's go ahead and break this edge off as well on the back of that relief there. Break off that sharp edge. Okay. We are ready to set up for threading. Because I use compound end feed, we're going to swing our top slide around here to the left side on 29.5. Then we'll have to square up our tool. That looks good. This one's going to be a little harder to get to. There we go. Okay. I think we got a threading tool up here somewhere. I thought I did. We'll take this one out and put it in we're going to put in our left-handed threading tool. This is the threading tool we're going to be using. This is a left-handed. In the previous pump shaft video, I explained in more detail why it's preferred to use the correct tool. If you're going to cut a left-handed thread, I'd prefer to use a left-handed tool. And the reason why is because you're cutting from the left to the right. So we're going to be cutting that direction, applying pressure against that side of the tool. You want the carbide insert to be backed up and supported by the tool itself, this material out here. If you was to use a right-handed tool, the one that I took off, right here, this is a grooving insert, but the same thing. So if you was to use this tool and you're feeding from the left to the right, the material is pushing that insert, and the only thing supporting it is that center screw. So that's why I recommend you use a left-handed tool if you're cutting left-handed threads there. So this is what we're going to use here. This is the Walter MX22. I really, really like these tools. These inserts work well. They last a long time, and you can get them in all different types of threading profiles and grooving tools as well. Round nose, square nose tools, they make a lot for that. All right, and then we need to loosen our tool post here. And I've got a machinist square. We'll use this guy. Just square it up. That looks good. see how this is going to work out. Okay, no, I'm going to have to move the steady rest down. I need a little bit more room to get down there to our thread relief. Okay, it is time to get the threads machined on the shaft, and what I want to do is go ahead and measure the pitch diameter of this existing shaft, and I'll show you how I'm going to do that. I don't have a pitch mic large enough, so to do these, I'm going to be using my granddad's tools, the thread triangles here. But here's the coupling, and I've got everything cleaned. This is what we want to make sure screws on there. This is the actual coupling that they're going to use. And if we screw this on there a little ways, it's got a good fit. It's got just the right amount of clearance there to it. So I think this has been machined to the proper specs. I'm going to go ahead and just check this side as well, just to make sure. Yeah, that feels good too. So our coupling is good. So we know if we cut our thread pitch diameter to this shaft right here, it'll be good. The coupling will fit. But I'd like to see whoever machined this, what they machined it to. So I'm going to grab my thread triangles. These are a little tricky to use, but so are the 3-wire method. I do not like the 3 wires. I think if I come up with some kind of tool where you could hold the 3 wires easily, I might use them, but I never have, and so these are my go-to. What I try to do is grab the bottom, hold the bottom with the bottom of the mic, and then slide the top in, and basically use the mic to kind of hold them in place because they will pop out. And then once you get it close, then I can kind of work the mic like you normally would when you're measuring the OD of something. And then once you get everything squared up and flat, it'll be good. That feels good. Now what I want to see is I'm going to go ahead and lock this. So that is 2.647. 2.647. That is what we're measuring pitch diameter using these triangles. All right, so if I come down here to my chart that is equipped with these triangles right here, so we're measuring 8 threads per inch. So this says for 8 threads per inch, you add 0.210, 210,006 All right, so we're going to figure, so our nominal size is 2 7/16, 2.4375 plus the figure for 8 threads per inch, which is 0.2106 equals 2.648 1/10. This is what you should be miking according to the chart here. Add the corresponding constant, which is B, to the OD of the threads. The total is the distance to mic over the triangles for a class 4 fit. 2.648 1/10, and I measured 647 2/10 on that. So that shaft is 1/1000, right at 1/1000 under what this chart is telling you it should measure. So we got a good thread right there. We got a good thread pitch. So as long as we're measuring very, very close to this right here, slightly under that, we should be good to go. So that's the target that we're shooting for right there, is 2.648. All right. If you don't have a set of these thread triangles, try to find some. I don't know if anybody's making them anymore, but maybe somebody is. These were sold by Raul Mike's Tool-O-Rama up in Springfield, New Jersey. And you want the chart with it there as well. This gives you lots of standard sizes from 0 up to 1.5 in different threads per inch, different classifications, but you don't even have to use that. If you're just cutting a thread, you can use these threads per inch columns right here, add this to your nominal size, and that's going to give you your thread pitch. It's a simplified version of measuring thread pitch diameters, I think. All right, so let's go over to the lathe and get these threads cut. All right, we need to get our quick change gearbox set up for 8 threads per inch. I'm gonna go ahead and get this moving here. All right, we want inch, 8, LBT1V. 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 We should be good to go. We'll make our scratch pass, verify it with our thread screw pitch gauge there, and then we'll be ready to continue on. All right, so I've got my cross slide set to a 0. I'm going to go ahead and 0 out our X on our DRO. I like to use both of them. I'm just going to come in here and touch it, set a 0 on my compound. There's our touch off, so we're going to set this one to a 0. Real quick, one of the main reasons why I like using compound end feed is that every time you finish the cut and you have to retract the tool back and bring it back into where you cut, you bring this cross slide back into a known distance, which is 0. It's always going to be 0. That's the only number you have to remember is 0. When you use straight end feed, where you're using this, if you're just doing a little bit of threading, I can see where that works really well. You're just doing a few passes and be done with it. But if you're making multiple passes over and over again, and you're trying to sneak up on a size, I don't want to think about what number I was on the last time I used the cross slide. So if you just go back to the 0 every time, you're going to be in the right position. And then when you want to feed the tool in a little bit more, you use the top slide. So that's why I use compound end feed. It's what I was taught when I first started doing machining. It makes total sense to me why you would do that, and this is what I stick to. So I'm trying to just, for folks that don't understand why you'd use that, that's what I'm trying to do, is explain that a little bit. All right, so now we've got it on 0. I'm going to feed in 2/1000ths so that we can make our scratch pass there. We've got this on a 0, DRO's on 0, and there's one thing that we did not do. I can tell by looking at, we're going to cut a right hand thread. We want to cut left-handed. So over here, we're going to switch this one over into reverse. All right, now I can see that the lead screw is rotating the opposite direction, and the feed dial, camera woman ran into the mill handle right there.
Sure did.
And now we're running in the correct direction. And I don't have to really worry about what number this is on because we're cutting 8 threads per inch. That's a 4 thread per inch lead screw. 8 is divisible by 4, meaning you can engage that anywhere you want. All right, so here we go. When you get to the end, nothing to worry about. Just simply disengage the half nuts, back this out. And this is where I'm talking about. You just come right back into a known number, which is 0. Right there, that's right where we started. You need to cut a little deeper, feed this one in. This one only changes when you feed it in there. So we got our screw pitch gauge set to 8. And you just want to verify it, and that's correct. So that means that our quick change is set in the right gear selection there. 8 threads per inch. So we're ready to start cutting. For 8 threads, theoretically, you're going to be going in with the compound set at 30 degrees, about 94/1000ths. And usually I have to go in a little bit further than that because that's a pretty sharp tool on there. So we'll probably end up going in close to 100/1000ths. Let's get our coolant going. We are running the same coolant that we run on all the other machines. This is the Master Fluid Solutions Trim Microsol 685 XT is the coolant. It works great. It's a good all-around coolant for any of our machines. All right, let's roll. I'm going to start with a 20/1000ths pass. Come right back into our 0, and we can verify that we're in the right spot up there. Let's take another 20 thousandths. Come back into our 0. Reset for another cut. So we are starting to, it's getting a slight amount of harmonics in the shaft. It's kind of normal for that. I just want to make sure the steady rest is tight, which it is. And I want to make sure that my tailstock is tight there as well. So that's about the best we can do. But what I want to do is go ahead and measure the pitch diameter and just kind of see where we are. We're getting real close. Oh, that one's coming out underneath the tailstock right there. Those stainless chips, those are the ones that'll hurt you. You gotta be real careful with them. Okay, I think things are looking good. That's Abby's favorite kind of exhaust that just went by. The snap, crackle, and pop exhaust. All right, let's see. This one's gonna be a little tricky to, it's gonna be kind of in the way for the camera, but we're gonna do the best we can here. If you can get the bottom hooked in, you can kind of keep it held with the micrometer. And I'm not looking at what the reading is. I just want to make sure that that everything is lined up the way it needs to be, and then you can feel it with the mic. So that one is 669. 669, and we were looking for 647. So you can see we got a little ways to go. All right, a good 20,000 still to take off on it. So we're gonna make a few passes. Now that we're getting down close to that full depth, I'm gonna back off on the depth that we're taking and just do like, you know, I'll do a 5 thou pass here, and then we'll probably back it down to like 2,000ths and 1,000ths from here. Try to get it cleaned up nice. I think we're going to try dropping the speed by 1 selection and see if it'll help with that harmonic. There we go. All right. 6:59. We're about 10 thou off. Sneaking up on it. Okay, I got 2/1000ths to come off of that pitch diameter. I'm going to try something here. I'm going to try a different live center. This is the live center that I typically always use. I love that style. It's an extended point, and I had this rebuilt by Ritten Industries. And it's a good center. But I've also got this live center from Ritten Industries that is a heavy-duty style live center. It's the quad bearing style. And I'm going to install it, and I'm just going to see if it helps the situation here. I don't know if it's going to do anything or not, but we're just going to give it a shot and see if it'll. I'm going to reduce. I'm going to bring the tailstock quill in as far as I can get it there. And the steady rest is tight. So let's see if that will help anything. I'll also slow down the speed. I'm simply just trying to get a little bit better finish on this. It's not bad, but it could be better. So I've slowed it down to the low range, running 105 RPM there. I'm just doing spring passes. I'm not going to take any depth here. I honestly think that helped. I think it helped. All right, I'm gonna keep measuring it because we're right there at it where we need to be. I'm so used to grabbing that other live center because it's my favorite one. I never really give much thought as to using a different center, but maybe in this case I should have. $6.49. Got another thou and a half to come out of it, so I'm just going to keep making these spring passes on here And I think we're going to be right where we want to be. That's cool. I really think the larger life center helped there. All right, what we got? So that is 648 and 3/10. I think we're going to be good right there. What I would like to do is let's go ahead and just check the coupling and see if it's going to fit on there. First thing I'm going to do though is I want to go ahead and just remove any of the burrs that might be on here. Just taking off any burrs, and then especially the one on the end right here. We'll clean that up a little bit more whenever we're through with the job completely. All right, let me get the coupling. I can tell that we need to take it down a little bit more. This is a machinist fit right here. This is super close. But let's take another spring pass, maybe even two, and give it a little bit of clearance, because there's just very, very little room of wiggle in there. And if it's too tight, it's easier for it to gall together, which is ultimately what we don't want in a situation like this. Come on out of there. There we go. All right, that was 2 spring passes there. I want to see where I landed on the pitch diameter. We didn't take a whole lot, but it did take some. There we go. Okay. Squared up nicely. At 647. And either 3 or 4/10. I think we landed right where we need to be on our pitch. Good to go. I'm going to go ahead and I'm going to do some more filing on it and get rid of the sharp burrs that are still on it. Need to get a file brush. Good. All right, we'll use a little bit of our power lube on here just to give it a little bit of lubrication for our thread check right here. I have a burr in my finger. You see it hanging out right there?
It's no good.
That was an easy one. That feels like it's supposed to right there. So just giving those couple of thousandths that we took is helping give it the right amount of clearance so it's not too tight. That's it. That's all the way at the end. It's screwed all the way on there. You can barely move that thing once it's all the way on there fully. Mission completed there. Did a good job. All right, guys, so the lathe work is complete on our shaft here. I'm real happy with that. So next phase, we're gonna be removing it from the lathe and we're gonna move right next door right here to the KBC mill. And I've already got the 2 vices set up and trammed. I did that ahead of time just so that it was done. But we'll be able to clamp our shaft in both of these vices and we'll be able to get to both keyways right here. The keyway will be on just each side of each one of the vices. So that's going to be a separate video. We're about to get started on that right now, but hopefully you enjoyed watching it up to this point and watching the lathe work there. And as always, I try to share a few tips and tricks along the way to maybe help you guys out. But I'm happy with it. I think we've got a good pump shaft. We just need to get our keyways milled in and this job will be done. So I hope you come back for the next video, all right? We'll see you then.